Before we can start balancing chemical reactions, we need to be able to determine whether we're talking about a physical or a chemical change. So in this video, we will be describing how we can tell if something is either a physical change or a chemical change, the latter of which would involve a chemical reaction. So what is a physical change? Changes that alter only the state or appearance, but not the composition, are physical changes. The atoms or molecules that compose a substance do not change their identity during a physical change. An example of this is water boiling. It changes its state going from liquid to gas, but the water molecules stay as H2O. So in the liquid form, they are very close together, held together by intermolecular forces. And when they go into the gas phase, they are free to move in three-dimensional space, but they are still H2O. The gas remains composed of water molecules, and so it is a physical change. On the other hand, changes that alter the composition of matter are chemical changes. During a chemical change, atoms rearrange, transforming the original substance into a different substance. A couple examples of this would be a rusting nail is an example of a chemical change. Rusting occurs when the iron atoms exchange electrons with the oxygen atom, combining to form a new or different chemical substance. Iron rust is composed of iron 3 oxide. So in the example of a rusting nail, you would have iron atoms, but once it oxidizes to form the iron 3 oxide, you'd have the introduction of oxygen atoms that form chemical bonds with the iron atoms. Because you are breaking the iron-iron atoms bonds and forming iron-oxygen bonds, we are undergoing a chemical change. So how can we differentiate one from the other? The primary difference between a physical and chemical change is the alteration of chemical bonds. If chemical bonds are broken, the change is a chemical change. If bonds are not broken, then it is a physical change. In general, though not always, if the process is reversible, it is an example of a physical change. Some of these include melting, the opposite of which is freezing, boiling, the opposite of which is condensation, sublimation, as opposed to deposition, evaporating a solvent in order to reverse dissolving. Now, this is one that can be a little bit tricky. There is a difference between having something like sugar dissolving in water and a salt dissolving in water. When we're looking at dissolving versus dissociation in water, salts will break their chemical bonds that are holding them together. However, things like sugar are breaking intermolecular forces. It does not change its chemical formula. So the process of evaporation and dissolution, dissolving, is an example of a physical change. Non-reversible processes are generally chemical changes. So burning or combustion, rusting, dissociation, so having the bonds break, or displacement type reactions are all examples of chemical changes. Let's now look at a couple problems where we are attempting to determine whether a process is a physical or chemical change. Pause the video and try to determine whether each one of the following processes is a physical or chemical change. Let's try the first one. Dry ice sublimating. This is the process where a solid goes to a gas. But in that process, it is a phase transition, so we are not breaking any chemical bonds. So this is a physical change. Wood burning, however, is the combination of some sort of a wood fuel, typically like a cellulose-like material, with oxygen. You are breaking apart the carbon-carbon bonds that are holding the wood together and typically forming carbon dioxide and water. So this is an example of a chemical change. Again, thinking of our determination of whether something is reversible or not, you can take dry ice that has sublimated and cool it down and get it to recondense or deposit as a solid. However, you can't take the ash and carbon dioxide from a burnt piece of wood and compress it to get a new fresh piece of wood. Another example is salt melting. If something melts, it is doing a phase transition from a solid to a liquid. The salt stays the same salt as it was before. The chemical formula is the same, and so this is an example of a physical change. Salt dissolving in water, however, is an example of a chemical change. The reason that salt dissolving in water is a chemical change is when salt goes into a water, the ionic bonds that are holding the salt molecule together are broken up, and the individual cations and anions become surrounded by water. Thus, the cation is no longer interacting with the anion. So this is an example of a chemical change. Sugar dissolving in water, however, is an example of a physical change. That is because you can reverse the process of dissolution by evaporating the water off, though technically you could also do this with salt dissolving in water. When sugar dissolves in water, however, you are not breaking any of the chemical bonds. The sugar stays sugar. And so this is an example of a physical change. When we cook an egg, we are denaturing and rearranging the protein structures, breaking some of the bonds that are holding those proteins together. This is an example of a chemical change. The egg itself cannot become uncooked, and that is your key indicator that this is a chemical change. A double displacement reaction is a type of chemical reaction in which one component comes in and displaces another. So this is an example of a chemical change. One of your key indicators for this is the word reaction.